Welcome to this brief introductory video on achieving and documenting tight tolerance roller dimensions. Oftentimes, this tight tolerance finishing is not only misunderstood, but frequently we don't pay attention to the critical details that go into achieving these tight tolerances. We will cover the three main building blocks that go into this, one being in the foundation, starting with the core. We will briefly cover how the covering matters, and then finally it's very critical to look at the final step of how we set up and do final finishing and grinding procedures. Pulling all three of those things together is key at the end with documenting the tolerances that we've achieved. But before we go into some of the technical details, I think a good question to ask is, why should I care? And there are a number of roller positions that benefit from tight tolerance. Speaking at a very kind of general level, anything that has to do with metering materials onto a substrate are great candidates for utilizing tight tolerance rollers. As you can see here, things like laminator rolls, metering rolls, silicone or any type of adhesive coating roll are great candidates. And so why does that tight tolerance matter? In many cases, you can have a significant reduction in the material you need to use, whether that be an adhesive or a paint, which can generate significant cost savings. For many customers, as much as $1 million of investment savings by utilizing tight tolerance rolls. When utilizing tight tolerance rolls, you can improve the quality of the coat weight application, meaning a very good quality but at less substrate applied. It also enables you to increase line speeds, and even in some roll positions which are not necessarily metering rolls, the tight tolerance capabilities allows you to have less wear and vibration, which can also translate back into increasing line speeds. So there's a number of reasons why tight tolerances can have a significant economic impact on your web processing machine. So where does it all start? It all starts with the core. And oftentimes we at American Roller see a lot of mistakes made at this very basic fundamental level. And we are not specifying today the concentricity requirements, but having a roll that is true TIR taper is really the fundamental piece. Oftentimes as well, we see rolls lacking a balance specification. There are all types of different ways to specify whether 2-plane or 3-plane balance, but having that balance specification is key. Here at American Roller Company, we design rolls for specific applications on specific machines. We do not take a generic approach when looking at tight tolerance roller finishing. So if you're approaching a tight tolerance roll with, well, we just need a core or we need a standard core drawing, and you're not really looking at the design of the core, the bearings, the concentricity specs, and the balance specs, you're probably not taking a comprehensive view of what it takes to have a successful tight tolerance roll. Because tolerance stack. So if we don't start with a good foundation, we're starting on a weak ground. Once we've addressed a good solid core, there's an awful lot of science and know-how that goes into what covering you choose. As you can see here on the slide, there's all kinds of reasons we choose coverings for different surface properties. And so understanding those surface property trade-offs and also understanding how that correlates into how you can finish it are key factors when it comes to achieving the tolerances that you're going to see at the end of this presentation. And so we here again at American Roller have over 600 different product catalogs for coverings that go across rubber, urethane, and hard coats. And understanding those trade-offs of temperature, chemical, coefficients of friction is important. But then once you've selected a covering, that consistency of how it applied is very critical, from a durometer to a uniformity, and again, the TIR and taper of the cover itself, which is another tolerance stack on top of the core. And then finally, if you've got a good core and you've picked the right covering and you understand how well you can finish that covering, the setup of the final grinding or the final finishing is very critical. looking at how you're going to finish it. Have you set it up in the machine properly? Do you have your final documentation of maybe a laser mic put forth? So all three of these, the core, the covering, and then the type of final finishing, not only in setup, but are you using belt or wheel? All these factors go into being able to achieve the finish that you desire. And if one of them is not thought through and not correlated to the other, your ability to see results will be diminished. Here's an example of two types of finishing setups. On the left here, maybe we're finishing a roller ground on journal centers, where oftentimes in a lot of the tight tolerance rolls we do, we're actually grinding on the bearings used on the roller installation itself. And so understanding what's needed and picking the right setup is, again, part of that critical finishing step. And then if you've done everything right, utilizing a pie tape or some manual process to document won't get the job done. And that's why we here at American Roller use a laser mic to digitally measure the performance of the finish from that core to the surface to the finishing, and set up both in TIR and Taper. And so here you see a picture of a roll with the laser mic set up that traverses across the entire length of the roll as it rotates, measuring full electronic measurement of the tolerances achieved. And here's an example to show you. What you're seeing here on this slide is a roll measured with a laser profile, or laser mic. So you can see the profile fitting very tight to the line there. And you can see on the tolerances that we're talking about hundredths of a decimal place. And that's on the left. But if you look to the right, we put a piece of human hair on the roll and reran the laser mic, and you can see that huge spike right in the middle of the chart, demonstrating the difference between a human hair and then the regular roll. Again, if you can imagine trying to do this with manual measurements written down on paper by an operator, it's just not going to cut the mustard. You really have to have a laser profile to really understand, are you getting what you think you're getting when it comes to tight tolerance finishing. We break down the definition of a tight tolerance into two categories, the rubber and the urethane, and then also the ceramic, plasma, or hard coating. So what you're seeing here is our rubber and urethane roll covering tolerances. On the left is what we typically call our standard tolerance. And on the right is the subject matter we've been talking about in this presentation, and that being the tight tolerance or more advanced finishes. It's interesting to note that the material that you pick has an impact on being able to achieve these advanced tolerances. Some rubber and urethane formulations do not finish to the level of advanced tolerances that others do. And so just not every rubber or every urethane roller will work for tight tolerance finishing. The material matters as well as that base core. This slide just shows you the same for our hard coats. These are the ceramics and the tungsten carbides, plasma coatings type finishes, again showing the standard tolerances on the left and our more advanced tolerances on the right. So as you can see, all of this comes together. It is not a simple, here's a drawing, give me this finish. The core has to be designed and balanced appropriate. The finish or the material needs to be selected with a lot of thought, and not only the polymer family of why we're choosing a material, but does that polymer family have the characteristics to be finished in advanced finishing? And then finally in the setup, are we going to be grinding on bearings? Are we going to be grinding on journal centers? And what type of grinding material or medium will we use in order to finish off the roller and achieve it? And then finally, you got to document it with laser profiles to demonstrate, because we're down to the hundredths and thousandths level measurement, which cannot be measured by the human man-made write it down on a quality sheet. Thanks for taking this time for a brief couple minutes just to introduce this. There's a lot that goes into this, so we really encourage you to download our white paper, and also you can get a copy of this PowerPoint. Thank you very much.